Welcome to The Explainer. So, if you're a PhD researcher or an academic staring down the barrel of a dissertation defense, or maybe a brutal journal review process, you absolutely know the anxiety. You've chosen a complex, hybrid methodology, combining the predictive power of partial least squares structural equation modeling, or PLS-SEM, with the configurational depth of fuzzy set qualitative comparative analysis, aka fsQCA. Look, it's a brilliant choice, but it's also a massive target for examiners. Today we're building your tactical battle plan. We're going to structure, format, and definitively defend this complex hybrid methodology so you can walk into that room with absolute confidence.
Now here's the high-stakes question you've got to be ready for. How do you prove your complex hybrid methodology is completely bulletproof? When a committee member zeroes in on your data, how do you show them that your structural models and your causal configurations aren't just, statistical illusions? Because it's not just about running the software. It's about how you build and report your argument.
Okay, let's dive into the roadmap we'll use today. We're covering structuring your hybrid methodology, the reflective model reliability checklist, HTMT versus Fornell-Larker, the fsQCA configuration table, and finally, essential robustness checks.
Section 1. Structuring your hybrid methodology, and specifically, the reporting hierarchy.
The evolution of modern quantitative inquiry really favors this hybrid approach. But listen, if your logic jumps around, you'll lose your examiners in a heartbeat. You literally must guide your committee through this exact four-step reporting sequence. First up, measurement validation. Second, hypothesis testing. Third, configurational results, which is where we transition into the qualitative realm. And finally, fit statistics. This strict hierarchy is a game changer. It allows examiners to trace your logic flawlessly from variable-oriented foundations right into case-oriented complexities.
Moving right along to Section 2, the reflective model reliability checklist, or as I like to call it, securing the foundation.
I really want you to treat this like a literal survival checklist. Before anyone believes your complex configurations, your underlying data just has to be rock solid. You need to memorize these minimum thresholds. Indicator reliability? That requires outer loadings greater than 0.708. Internal consistency? You'll need a composite reliability greater than 0.70. And convergent validity needs an average variance extracted strictly greater than 0.50. Just rattling these off builds an absolutely undeniable foundation for your work.
Section 3. HTMT versus Fornell-Larker, which is all about upgrading your toolkit. This is exactly where so many researchers get tripped up by outdated methods. For years, the Fornell-Larker criterion was the go-to metric, right? But the literature now explicitly states it struggles to find validity problems that are actually there. You simply must upgrade to the heterotrait-monotrait ratio, or HMT. It's an estimate of the true disattenuated correlation. Honestly, this is the cutting-edge standard your committee expects to see. Back in the day, you might proudly display a classic Fornell-Larker matrix, ensuring the diagonal AVE square roots were higher than the correlations below them. But as we just established, a clean-looking table might be completely hiding severe validity problems. We just have to move past it.
So instead, you want to use the modern HTMT output. To prove true discriminant validity, your HTMT values absolutely must sit firmly under the conservative 0.85 threshold, or 0.90 if you're dealing with conceptually similar constructs. Highlighting this proves you aren't just pressing buttons. It shows you genuinely understand the latest methodological advancements.
All right, on to Section 4, the fsQCA configuration table, where we'll be decoding the visual language.
Once your linear models are completely validated, you transition into causal complexity. And there is a highly standardized visual language your committee expects when you format your fsQCA configuration table. It's all about iconography. A large circle represents a core condition. A small circle is a peripheral condition. A solid black circle means the condition's presence is required, while a crossed circle means its absence is required. Mastering this specific visual vocabulary makes your findings instantly readable to anyone on your panel.
Now, the absolute crucial point when discussing these configurations is cementing the 0.75 consistency rule. Consistency represents the degree to which a causal configuration leads to an outcome. You can think of it kind of like a test for sufficiency. Basically, if your consistency is below 0.75, you simply cannot reliably claim that your configuration is sufficient to produce the result. You really want to hammer this number home. It proves your qualitative findings are grounded in rigorous mathematical thresholds.
Bringing us to Section 5, Essential Robustness Checks, the ultimate defense.
So, you've presented beautiful models and these fascinating visuals, but now you have to prove your hard-won findings aren't just some fragile illusion.
This is literally the ultimate examiner trap question. What happens if you tweak the thresholds? Are your configurations truly stable, or just artifacts of the software settings you happen to choose?
To survive this trap, you've got to arm yourself with a precise 3-step sensitivity check. First up, vary your frequency thresholds in the truth table. Second, adjust your consistency and PRI thresholds. And third, and honestly, perhaps most importantly, recalibrate your qualitative anchors. So for example, if you used a 7-point Laggard scale, show them what happens if you shift the crossover point of maximum ambiguity from a 4 to a 4.5. By running these exact robustness checks, you definitively prove that your core findings remain stable, even under the most rigorous, hostile academic scrutiny.
This really summarizes the entire philosophy behind your methodological choice. You aren't just using 2 tools just for the fun of it, right? You're performing triangulation. PLS-SEM gives you the stable, generalizable foundation for average net effects. But fsQCA steps in to provide the contextual depth. It shows how multiple causes work together in different combinations to generate the outcome. It's an incredibly realistic, sophisticated representation of causal complexity.
You now have the structural hierarchy, the reliability checklist, the HTMT standard, the visual vocabulary, and the ultimate robustness checks. Your hybrid methodology is no longer a vulnerability, it's practically an impenetrable fortress. So, knowing that your data is safe from any methodological attack, what groundbreaking insights will you confidently defend next? Thank you so much for joining me on this explainer. And hey, best of luck on your defense!